All right. How much did I make an hour if I made $36 in 4 hours? How much? Go ahead. Yep.
$9 per hour.
$9 an hour. That works. A 10-ounce bottle of shampoo costs $2. What's the cost per ounce? 20 cents per ounce. So $2 divided by 10. A 3-pound package of hamburger costs $9. What is the cost per pound? $3. Those weren't necessarily the cross multiplication ones, were they? They were just kind of just how to divide. Okay. And then number 4, we have 5 over 6 equals x over 18. So by using cross multiplication, we probably find that it's 15.
Yeah.
Is that it? Yep. And then the next one, we got, what'd you get?
40.
35?
Yeah.
Okay, I'll take 30. Is it 35? Yeah. Yeah, it's 35. Okay. Oh, and there's a hand in the way.
And get out of here.
Okay. And then this one, I have 2 over 5 equals x minus 2 over 15. So on this one, when you cross multiply, you have to make sure you go.
Wait, how did we get 35?
How do we get 35 on this one?
Yeah.
2n equals 60.
No, 70.
70, sorry. And then divide each side by 2, so you get 35. Right? And then this one, I get this. So that's that cross times that. I'm going to choose to divide each side by 5 first. And then add. So it looks like x is equal to 8 on that one. And then what percent of 60 is 15? So my of is 60, my is 15. So I go is over of equals percent over 100. So what am I looking for up here? Well, it says what percent, so I guess that'd be x. So I'm going to get 15 over 60 equals x over 100. Cross multiplication, so you get 60x equals 1500. Divide each side by 60, so 25%? No. No. Yes?
Yeah.
Okay, cool. All right, find 40% of 70. So what letter is missing up here? I'm missing what word? In our, I'm missing is, so is must be my unknown, of 70 and 40 over 100. And again, 100 is your constant, so cross multiplication, 100x is equal to 2800, so x equals 28. All right? What percent of 14 is 28? So I'm still looking for the percent here. So of is 24, is 28. Cross multiplication, I get 14x equals 2800, so 200%.
Yep.
Man. All right, so we'll pause there for a sec. So the is over of equals percent over 100. I'll always put it up on the board for you. I'd rather you know where to find it rather than, pack it in your brain and, you forget like something else or something. Can I move on? Yeah, buddy. All right, now there was one here, or some that I asked you to skip, but I just want to go over them real quick. So 10 and 11, but we can do all right, I think we can do this. So I'm going to go new minus original, and then I'm going to go we'll make it work. So from 3 to 2. 3 to 2. So is this a decrease or an increase? God bless you. It's a decrease. If it's a decrease, my answer should be negative. Okay? All right, so I'm going to go 2 minus 3. So I get negative 1. And then what? Then this over my original. Negative 0.5, and then multiply that by 100. So negative 50%, so it's a 50% decrease. Okay, 9 meters to 12 meters. So 9 to 12. Going from 9 meters to 12 meters. Am I increasing or decreasing? I'm increasing. That's an increase. Okay. So I'm going to go 12 minus 9 is 3. And then I'm going to go 3 over 12 equals what? 0.25. Multiply that by 100. So it's a 25% increase. All right. Physical therapist measures strength on a dynamometer. That's kind of a dynamometer. It's a fun.
Dynamometer.
Thanks, man. You got it. I wanted to go more funner. Funner is the funner way to the funner.
There's always a fun way.
I wanted to go dynamite, but I can't. Which uses a unit called foot-pound. Suppose you increase the strength in your elbow joint from 90 foot-pounds to 125. So if that's an increase, find the percent of the increase to the nearest percent. What is that, 35? And then I'm going to go 35 over 90. Help me out. I don't have a calculator with me. I'm sorry. There's 35 divided by 90.
0.38.
So multiply that by 100.
38.88.
So 38.9% increase. Sweet. A marathon runner completes the 42.2 kilometers of a race in 160 minutes. At the same rate, how far would you expect him to run in 120 minutes? Oh, wait a minute. So they did 42.2 in 160 minutes. Still with me on this adventure? We want to know how far they would have ran in 120 minutes. So would they have run less or more? Yeah, they would have run a lesser distance. So I'm going to cross multiply. So you get 160x is equal to 42.2 times 120. Don't know what that is, but what'd you get for an answer? What do you think? What do we get? Plus that. So look at. Oh, it does work. 42.2 times 20 equals that divided by 160. So it looks like 31.65 kilometers. Judy works at Biff's Big Burger. Biff's Big Burger. Okay. She can cook 12 hamburgers in 4 minutes. At this rate, how many hamburgers can she cook in 60 minutes? So 12 burgers in 4 minutes. How many can she cook in 60 minutes? Cross multiply, so 12 times 60 is 720, divided by 12. 60 hamburgers? Did I do that right? Wait.
Divided by 4.
5, how much was it?
4.
4? What?
12 times
720
720
divided by 4. Oh, I divided by 12. Why did I do that?
4.
180 burgers. Nice.
Oh,
All right, you go out to lunch and your bill comes to $10.50. If you leave a tip for 15%, how much should you leave? You go out to lunch and your bill comes to $10.50. You leave a 15% tip. How much should you leave? So hang on, this is kind of a goofy question because one, the bill comes to $10.50. So did I pay and then go back and put the tip back on the table, or am I just leaving the total and the tip on the table? Yeah.
Can I answer it?
Yeah.
It's $12.07.
12.07. Okay, let's think about this. I think it might be right. So I'm going to do this, and I'm going to multiply that by 0.15, right? Is that right? Times 0.15. So that's roughly $1.58, right? So the tip is $1.58. If you were leaving everything on the table, you'd add $1.58 back to your $10.50. And I'd get $12.08. Cool. I think we're okay with that. Tipping's a tough one, isn't it? You know what's wrong with tipping these days? Is there are places that expect you to tip that aren't tippable entities, and then places that you should tip, people aren't leaving enough. You know, if you go to McDonald's and there's a tip jar on the counter, they did their job. You don't tip that. If you go over there to the Village Inn or some other place to have breakfast, and a waiter or waitress brings you your food, you are expected to tip. Do you know that if you don't tip, they have the right to refuse you service? Tipping is expected and it's not optional. And I worked in the restaurant industry for years. And we had people that would come in and they would not leave a tip. And my manager often would go out and say, hey, was there something wrong with the service? Oh no, service is great. Oh, great. Was there something wrong with food? No, food was great. Was there anything you're concerned about with how the restaurant runs? Oh, we don't believe in tipping. If you show back up to our restaurant, we will have you cited for trespassing. Done. Well, you're going to lose our business. We don't want it. No. You, in a wait staff environment, you are expected to tip. The waiter or waitress is making less than minimum wage and will make more than minimum wage because of the tips that are collected. So, don't tip. It's kind of hard. I'll just leave you $1. I'll tell you what, the one that really frustrates you as a server is you have a rowdier table. Now, here you go. Here's $0.25. Good job. Really? Which car is yours out there? Oh, that one. I'm going to throw a brick through your front windshield.
Use that extra money that you didn't pay me to fix
It's it's pretty sad. I mean, the thing is, food is relatively inexpensive. Now, there are restaurants out there that are, because of how the whole process of tipping is taking place, they've increased the value of their meals by 20%, and so the waiter or waitress automatically gets that 20%, tagged onto that bill. And so people are like, well, that's not right. Then don't go to the restaurant. Well, what if I like it? Then quit belly aching. It's one of those things, and I would encourage each and every one of you, if you ever get the opportunity, work in the restaurant industry. It's a fun industry. It's different. Boy, you got some strange cats that work in the people that work in that industry. But I'll tell you what, it's fun. Then I flip over the page. It says the car magazine is writing a story about 4 cars. For each car, they will report the number of miles driven for the different amount of gas. The table shows the number of miles driven by car A for a different amount of gas. If car A uses gas at a constant rate, fill in the blanks. Okay. So let's figure this out. Gallons, miles. I got a blank here, and then this is 10. I got 330 here, and that's 15. I got 440 here. That's blank, and I get blank here, and that's 24. So which one's going to determine our ratio?
30, 30, and 15.
Yeah, so I am going to go 330 divided by 15, and this is going to give me my rate at which this car is going to do. So I'm going to call M over G is what we're going to use. Okay? And that's going to give me my rate. Okay? Help me out here. That's 22. So my rate of my car is 22. So let's figure this one out. If I have a question mark here, I have question mark over 10 is equal to 22. How do I solve for question mark? Yeah, 22 times 10, so this is going to be 220. Got a question mark down here, okay? So that gives me 440 over question mark is equal to the 22. How do I solve that? Yeah. How do you do that? You multiply, so you get 22 question mark equals 440. And then you divide each side by 22, so you get 20. And then this one, same thing. Question mark up here, question mark over 24 is equal to 22. Multiply both sides by 24. What does that come out to? 528. Thank you. Sweet. Oh, cool. Now we got to do some more conversions. I like these conversions.
Yes.
And I tell you, guys and girls, I am not fibbing to you. If you choose to go on to college, which most of you should consider this, you should indeed get this skill down. And when you get the skill down, you take physics, because this skill will really help you. Okay, 26.1 miles is how many meters? Well, so wait, what do we know? What? 1 mile is what?
528.
We don't have miles to kilometers? No. Oh. So 1 mile is 5280 feet.
No, there is a
Oh, there's a kilometer. A kilometer to what? A kilometer to meters, right? Okay, hang on. Time out. On the right. Where? 1 mile. Wait, where? Oh, really?
No.
Oh, dude, it is right there. Okay, I thought you guys were funning me for a minute. All right, so whoa. All right, 1 mile is equal to 1.609 kilometers. Okay, so right now, if I did that math, it's going to cancel out miles, so that and that are gone. So my answer is in kilometers. But I know that 1 kilometer, I'll tell you, is how many meters? 1,000. Good. All right. So now that's going to cancel with that. So 26.1 times 1.609 times 1,000.
4,000.
Say what? 4,000. How much? It's okay. I heard a 4. That's about all I heard.
Yeah, 41,000.
934.9?
94.
994.9? 91732834979 pi. Greek letters.
Is that your pie and your phone number? God, no wonder nobody calls you. Oh, are you gonna take that roast?
Over.
Go take it.
Do you want to know something that's weird about pi? If you, huh? You eat it? The diameter, or the circumference of any circle divided by the diameter. So, you guys all have heard that pi is a non-stop going decimal, right? Do you know you can find your phone number in pi?
No, you can't.
Any phone number, seriously. Because it is an infinite string of numbers. So if you go, and so I'll put this on you guys. You go find how far you can take out pi on the computer, and then do a Google search for your phone number in pi, and it'll tell you. So like go Google, is this number in pi? So whatever your phone number is in pi. Yeah.
Will it like be in a row?
Yes.
So like you could highlight it
Yes.
and call it, and it would be.
Yes.
That's awesome.
Crazy. I mean, it's hard to fathom. Going, there's no way that happens. No, you got to
It's an
trust.
infinite number of strings. It's an infinite number of numbers. All in
With
a row.
no pattern to it, no rhyme or reason to it.
Random at all.
So it's not going to be like the first 5 digits. It's could be embedded a couple million lines into it. It's crazy.
That's cool.
Yeah, I think it is kind of cool. So what'd you learn in math today? Oh, some more useless stuff that guy told us about pi. I like cherry pie better. Grapes, I think, baby. It's great.
Peach pies.
Well, I like peach pie.
Good. Banana cream. No.
Banana cream I like as well.
I don't have banana cream right now. We're in math class. Too sloppy.
Say what? Alright. So I got this in meters per second. I want it in miles per hour. So let's convert the meters first. Oh, what do we know? I know that 1 mile is 1.609 kilometers. I know that 1,000 oh yeah, so I gotta do this. One kilometer, boy, I can't write. 1,000 meters. So that's actually canceling that. That's going to cancel that. Check on the miles. So, and then I want to get seconds an hour. So that I know that 60 minutes is 1 hour.
60 seconds.
And 60 seconds is in 1 minute. The minutes now cancel. The seconds cancel. That leaves me miles per hour. So you're going to go 340.29 divided by 1.609, enter. Divided by 1,000, enter. Times 60, enter. Times 60, enter. And you get some breakdown. Ooh, the speed of light. Wow. Speed of light. 299,792,458 meters per second. You ain't kidding. What are they waiting for? You feel okay about these?
Yeah.
Any of these you want worked out? So, while we're talking about big numbers, this is off topic, but I think you guys will be okay. Any of y'all see this number in your science class? Avogadro's number? You seen this before? Avogadro. Seriously, this is the guy's name.
Avocado.
Avocado, yes, you're right. Avogadro. Okay?
Avocado.
So, Avogadro's number, that is 1 mole.
Oh.
And if you have a mole of something, that's how many you have. So they say, back there, bust
It's
out
a
the
mole
song.
song from Mr. Winterhalter's 8th period.
There you go. Alright, so if you have a mole of something, what that basically means is if you have 1 gram of a pure substance, like 1 gram of gold, 1 gram of anything you find on the periodic table, you have that many molecules of that particular atom. Okay? But let's take Avogadro's number and talk about it in the sense of pennies. Pennies.
Oh,
You know
yeah.
those little copper things you don't pick up.
That's ridiculous.
Yeah, you don't pick up off the ground. You know what I'm talking about? Still with me? All right. Someone got a calculator?
Yes.
All right. If you have a calculator, plug this into your calculator like that. Okay? Unless yours has a scientific notation. What? Yours can do E? Does it do scientific notation?
Yeah.
And let's see if I can do it too. I'm going to break out with this one. All right. Clear? 6.02 e 23rd.
Yay, I got 6.02 times 10 to the 23rd power.
Sweet. All right. So I want to convert from pennies to dollars. You still with me? Pennies to dollars. You still with me? Pennies to dollars. All right. So pennies to dollars. How many pennies are in a dollar?
100.
100. So divide this by 100. So go divided by 100. And then you should have 6.02 times 10 to the 21st dollars. Okay? I want to give you permission right now. If you have Google on your phone, use it right now. And will somebody find for me what the current population of the planet would be?
Oh, I was on this the other day.
It's billions. Yes, you're right. I want to know what it's at right now.
Here, I'll tell you.
You getting there?
Yeah. There's a
How
world
many-
population clock.
Yeah, here you go. That'll work.
7 billion.
Well, people have babies.
No.
Okay, so.
Yeah.
Alright,
Hang on.
alright,
Shh. Go ahead.
7.125
125 billion. Is that what you said?
I got 7,374,000.
Yeah. 7,374
74. Keep
million.
Yeah, 041.
041.
2, 5, and then the last number keeps changing.
Call it 9. How's that?
Okay.
So that's this by your clock. That was like 10 minutes ago. So this particular clock basically has the birth rate, and by it working the way it does, it also takes into account the death rate. The birth rate is greater than the death rate, so the population is increasing. Does that make sense? So remember, if I divide this by 100, this gives me dollars. So ready? I'm going to divide by 6.02 times e to the 21st dollars by that population. 7,374,041,259. So if we had 1 mole of pennies, that means that every man, woman, and child. 3, 1, 4, 5. Hang on. Let's see. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. So that means that every man, woman, and child on the planet at that current population, which was a few minutes ago, that's how much money they get. We're talking about $816 billion. Now, let's break that into a numeric value that we can deal with. The average life expectancy of a human worldwide is 65 years old. It's greater than in the United States, but as far as the whole planets, so that means in 65 years,
We're probably gonna be dead. That's what I said, probably.
1, 2, 3, 4.
I did that, and I got 1.255965099.
So what this means now, if the average age is 65 worldwide, that means, so average means you sum up people who die like right now, there's people that die later. So every year of that person's life, they get to spend $12,559,650,990. Okay, that still doesn't mean that much to me. So that's what they get to spend per year. But now I realize that we're going to go divide by 365.25 because we're dealing with leap year. So this means each day, 8, 6, 4, 5, 0, 4, 3, 6. Each day of your life, you get to spend 34 million, $386,450.36 each day of your life if we had 1 mole of pennies and we divided it equally amongst every man, woman, and child. But it still doesn't mean much to me. I want to know how much I can spend each hour, so I'm going to divide that by 24. I'll just keep it there. So this means that each minute of the day I spend 1,432,760 for each hour. So that's each hour of the day. Oh wait, yeah, that's each hour of the day. So if I divide that by 60, so 23879.48 roughly. So that's how much you got to spend per minute. Still doesn't mean much to me. I want to know how much I could spend each second. So it means you could spend $397.99 a minute or a second. I don't know about you, but I'm up for the challenge.
Same, I'll take it.
Giddy up.
I'll
Let's
take
do
it.
it.
Let's go.
And then everything else will be.
So that's if trickle down economy actually works.
Yeah. Hurry up. All right. So, good stuff. All right, so your assignment has nothing to do with this. I just thought it'd be fun just to talk a little off the cuff about big numbers because we were starting to deal with some big numbers.
Oh, speaking of the mole,
Yeah?
look up the mole song real quick.
Page 63, 64, which is worksheet number 3.
Wait, when's the next test?
A week from tomorrow, or actually a week from today, I believe. I think.
Yes.
I like it.